Number 11. 2x squared minus 72, that one? Yep. All right. So let's start solving this to get x squared alone. So add 72 to both sides. So those cancel. And then divide each side by 2. Those cancel. 2 goes into 72 36 times. Right? 2 goes into 72 36 times. Root, don't forget plus minus. Square root of 36 is 6, so I get plus or minus 6. What else would you like to take a look at? Yes, sir. Number 5. 3 root 28. Is that it? Okay. So think about our perfect squares. So root 28 falls about there. So 4 times 7 will give me that. Square root of 4 is 2. So that comes outside, and you're left with that. So you wind up with 6 root 7 for an answer. What else could I help you with? I think on the, yeah. 8. Thanks for asking me number 8, because this is one of our newest ideas is going to happen here. So subtract 8, subtract 8. We're good there and there. Those cancel. I'm going to go root. Don't forget plus minus. What did I say to do when you have a negative under the radical now? What do I want you to put? Yeah, so you're going to get I root 8. There's a plus minus in front of it. But then you can break 8 down. 8's going to break down to 4 times 2. Square root of 4 is 2. So you can have this for an answer. And you're in the imaginary numbers now. Hee-haw. Any other problems you wanted to take a look at? I think there might have been one on this back page. I think. Yeah, go ahead. 9. Number 9, I get 2x squared plus 10 equals 0. Let's get x squared alone. So subtract 10 from both sides. Those cancel. Ooh, someone's birthday. Let's go get cake. X squared equals negative 5. Root, don't forget the plus number, plus minus. Now we have an imaginary number. So we have plus or minus I. I cannot break down square root of 5, so it's plus or minus I root 5. Yeah. 12. Number 12, I got negative x squared plus 25. Yeah, the plus minus. Oh, yeah. The plus minus indicates 2. All right, so let's see. Subtract 25, subtract 25. Those both cancel. Multiply both sides by negative 1. This is the only time that when you root, the plus minus isn't really needed. The square root of 0 is 0, so you could have plus or minus 0, but you realize 0 is only it's not positive or negative. So if you put either of those answers, you're totally right. Yeah. 10. X squared minus 24 equals 40. So I'm going to add 24 to both sides. Those cancel. So that's 64. Root, don't forget the plus minus. Okay, so plus minus. Square root of 64. 8. There you go. So your answers are positive 8 and negative 8. So you can write it as plus minus 8. Now there's one they snuck in on you, and I didn't realize it was there. I'm going to go to number 15. Number 15, you have these parentheses, quantity squared equals 49. Okay? Now, This is done the same way. So at this point, I have a quantity squared. So to undo a quantity squared, take the square root. Don't forget the plus minus. Are you still with me? Square root of 49 is 7. Now, this is where you might want to break the problem into two, because it becomes one of those that you start looking at a lot of work in your head if you don't. So that's where the plus minus 7 happened. Now I need to solve for x. Divide by 3, divide by 3. X equals 2. 8. This one, subtract 1 and subtract 1. Those cancels. 3x is equal to negative 8. So x equals negative 8 thirds. So there's our two answers. Those are both the answers for this problem, okay? Mikey, did you have last night's homework? Anything else I could help you with? Going once, going twice? Going 3 times? All right. You need to forgive me for today's lesson, because I'm going to put a song in your head, and it's not going to leave. And I'm sorry. And I actually know the song stays in your head because I actually have students that have emailed me from years back saying, yeah, we were working this thing, and I had to use that formula that you sang the song to us for, and it's still stuck in my head. Good. So I am on page 161. 161. So let's get to right here. All right. Page 161. Oh my gosh. All right. So this quadratic formula can be sang. I have a video link here that will sing it to you. Now you're like, cool, we're going to watch a video. And all of a sudden it's like, dude, it's stuck in my head. Okay, make sure we turn that up a little bit. Here we go. This is how you're going to remember this song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, we'll repeat it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, you're like, I don't know what that was, Stirrup, but please don't play it ever, 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 ever again.
In this video, I'm going to expose you to what is maybe one of at least the top 5 most useful formulas in mathematics.
No. It scared me a little bit because it said, I'm going to expose you to. I'm like, oh no. Oh no. What video queued up next after the quadratic formula song? All right. So the quadratic formula is a very useful formula that works when you have a quadratic. Now notice A, B, and C are when we would have numbers. Okay? Notice the A value falls right next to x squared. The B value falls right next to the x value, and the C value falls where you don't have the x values at all. Notice in the equation, we're solving for x. Remember, this has 2 answers, so this is going to justify there's 2 answers. Now, my friends, I know that you are dependent on electronics, which is fine. if I square a negative number, what do you guarantee I always get? Positive, right? Say it one more time. If I square a negative number, I get a. If I square a negative number, I get a. If I square a negative number, I get a. Okay. Now I'm going to show you why this is goofed up. So you know that. You know, hey, I have a number squared. It's got to be positive. You know that. It's written into you. So I'm going to pull up a graphing calculator. Okay? Now, you know deep down inside, anytime I square a negative number, it's positive. But watch what happens here. Ready? So -4 squared. What can you guarantee me the answer has got to be? It's got to be positive 16, right? -4 times -4 is guaranteed to be 16. You all agree? You're all watching up there, right? So -4 times -4 is guaranteed. You know this has been embedded in you since you started squaring. It's got to be positive 16. So this is what the calculator sees that as. So we know that -4 squared is equal to 16. There's no doubt. Hello. Thank you very much. Cool. So we know that. We technically know it. So this is what the calculator thinks is happening. They think you're going -1 times 4 squared, which would be -1 times 16, which is -16. That's what the calculator is doing. So if you are ever in doubt with a negative, like you're not going to discover some number that you square that's negative that comes out to a negative number. It's not going to happen. Okay? So whenever in doubt, if you wanted to plug something into a calculator, you know you have to put it in parentheses, which that will come out. If I do that on the calculator, if I do that on the calculator, then it comes out what we've always known. Okay? Now, I've got to warn you on that because notice what value is squared. It's our b value squared. Agree? So sometimes this might be -3 or -7 or -8. You know that when you square a negative number, it has to be positive. But you become so dependent on technology is always going to be right. Technology is right if you understand how the iteration takes place on the calculator. And again, if you have a negative number that's squared and you don't group it, so you don't put it in parentheses, the calculator thinks it's basically -1 times that number is squared. Okay? So let's look to where this equation, there are some errors that take place often. Sometimes, because that's a -b, sometimes you forget to put that negative. The next common place for an error is there. And then the next common error is when you do the math underneath here. Okay? This is one of those going, oh, I can do it in my head. I'm not asking you to write extra steps down because I'm so proud of what you know. I'm just saying, you know that a negative number squared is a positive. So don't rely solely on the calculator saying, oh, the calculator is smarter than I am. No. Humans wrote the program for the calculator. It's not smarter than you. Okay, so be cautious on that. So let's take a look at this problem. Okay, so things that I want to just put in place. Would you all feel comfortable that there's a 1 in front of that? Yeah. Is anyone like, you're okay with that, right? So I know that my A value is 1. My B value is what? -4. And my C value is? So does everyone feel comfortable how I came with that? Now, when we were graphing parabolas, we were still doing the A's, B's, and C's, right? So the A, B's, and C's is not a new term. The A value always goes along with the x squared term. The B value goes along with the x term. And the C value is the term that doesn't have an x or a letter associated with it. So, quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's the quadratic formula. Okay, ready? I'm going to go slow. Okay, what do you know about that sign right there? It's negative. Now, what's my b value? Okay, are you okay with that? You see how I have a negative, negative? What do you know that's going to be eventually? Positive, okay? Plus or minus square root b squared minus 4ac all divided by 2a. Okay? So these are the values where I plugged them in. 1 goes here. Okay, that's my a value. 1 goes here as well. That's also an a value. B goes here and here. And then C goes here. Notice there is a 4 and a 2 that are already in there. Okay? We can prove this equation by using something called completing the square to get there. Completing the square, all that is you remember when we were graphing parabolas and there was something called vertex form? And we found that vertex form became our best friend because when you had it in vertex form, it gave you the vertex, and once you knew the vertex, you just could pattern graph off of that. Completing the square finds you vertex form of a quadratic. Okay? But if I use the A, B, and C with quadratic formula and I do something called completing the square, which is not something that you'll learn this year, you'll learn it during Algebra 2, you can prove that the quadratic formula works. Okay? So let's go ahead and do the math that's going in here. So what do we guarantee that's going to be? Positive 4. Now, can you see how you might be like, oh, there's too many signs, so I'm just might forget to put something? It happens. Plus minus. What can you guarantee that negative 4 quantity squared is equal to? 16. And then I'm going to go negative 4 times 1 is negative 4. Negative 4 times negative 2. Negative times negative is positive, so I'm going to get positive 8, all divided by 2 times 1, which is 2. Clean it up a little bit. Okay. If you got to that, that would be probably a 4-point problem. If you got to right there, you're going to miss 1 point. Why? Yeah, what's not broken down? You're absolutely right. The 24, excellent. The 24 can break down. So let's take that 24, that root 24, and let's break it down. Root 24, do you feel comfortable that that is going to be 4 times 6? Yes, it's also 3 times 8, but what did I do with 4 and 6? What's good about that? 4 is a perfect square. So square root of 4 is 2, so I get 2 square root 6. So now, where I have the root 24, I'm going to replace that with 2 root 6. Now, if you got to that point on this problem, I'm proud of you. But you're going to miss a half of a point. So you don't want to miss out on a half point. We want all the points that are available. So remember when we were saying things that are outside the radical, we can reduce? What number does it appear that 4, 2, and 2 all have in common? 2. So I'm going to say, all right, well, 2 goes into self once, goes into self once, goes into 4 twice. So my answer to this is truly 2 plus or minus square root 6. Yes, you could have the 1 in front of it. It's over 1, but this is what my answer is. That's 2 answers. That's 2 plus the square root of 6 and 2 minus the square root of 6. And that is what they call an irrational number, which is fine. that right there would be the location that if I had drawn this as a parabola, my parabola would cross the x-axis at 2 plus root 6 and 2 minus root 6. Okay? So it's a newer idea. Okay, so this is a new tool. So if we look at this next problem here, you might want to, there's a big blank at the bottom of your paper. You might not be able to squeeze as much there unless you write really small, which is fine. If we factor this, basically I know I have a 1 out front here. I'm going to multiply 6 times 1. I get positive 6. Looking at that, I get positive, positive. The two factors of 6 are 1 and 6 and 2 and 3. Which one of those, if they were both positive, would add up to be the positive 5? 2 and 3. So I get x squared plus 2x plus 3x plus 6. I have an x in common here. That middle sign comes down. I can factor 3 out here. And then I get x plus 2 and x plus 3, which those are equal to 0. So this is going to tell me x equals negative 2, x equals negative 3. Okay? This might be a faster method for you to do. Or I could go to the quadratic formula. The quadratic formula, I know my a value is 1, my b value is 5, and my c value is 6. And we know that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and plug it in. Negative b is negative 5 plus or minus 5 squared minus 4 times a times c all over 2 times a. So x is equal to negative 5 plus or minus 5 squared, 25. Negative 4 times 1, negative 4. Negative 4 times 6, negative 24. What's 25 minus 24? 1. What's the square root of 1? Okay. Now how I'm going to get my answers? Ready? Negative 5 plus 1, negative 4. Agree? Negative 5 plus 1, negative 4. Negative 4 divided by 2. Negative 4 divided by 2. There's one answer. Negative 5 minus 1, negative 6. Negative 5 minus 1 is negative 6. Negative 6 divided by 2, negative 3. Okay, they're both going to get you to the same outcome. The nice thing is, if it factors in mathematics, you can solve it pretty easily. If it doesn't factor easily, then the quadratic formula. Now, I'm not going to tell you on a problem, hey, you have to factor this one. You can jump right to the quadratic formula and go for it. Okay? But the unfortunate thing is the quadratic formula has a lot of places where with arithmetic you might make a mistake. Okay, so just be very cautious when you're doing that. Okay? So let's take a look at the next problem on our page. So I have this one. So it's things I have to do. I have to make sure it's equal to 0. You okay with that? Now, before I do anything else to this problem, I would say, let's go ahead and reduce it. What number could I divide 2 and 6 and 20 by to get it smaller? 2. Okay? Now, if you don't do that, it's still going to work, especially on the quadratic. So that's going to give me x squared minus 3x minus 10 equals 0. Now, some of you might get quicker at factoring, especially on this next way. If I factor this out, if you see it, okay, this way, this quick way only works when I have x squared by itself. If I don't have x squared, if I have like 7x squared, it's not going to work as nicely. Okay, you can still do it, but watch this. Ready? I know I have alternating signs. Okay, the reason I know that, I have a negative 10 there. Okay, think about the factors of 10. 1 and 10 and 1 and 10 and 5 and 2. Okay, which one of those has to be positive and which has to be negative? That's going to add up to negative 3. Negative 5, positive 2. You just factored it. So x equals negative 2, x equals positive 5. Okay, so this is a quicker way of factoring it, because if you start seeing the pattern with it, and the reason I didn't show that originally on the factoring was I wanted the factoring to continue to go the same way every time. Okay, there's different ways. There's a rule that you might start hearing in math called the 90-10 rule with factoring. And all it basically means is when you factor, you usually pick the two numbers closest together. It works like 90% of the time. Sometimes we might call it the 80-20 rule, saying it works 80% of the time. I can't guarantee the exact ratio of it, but that happens. But let's look at this and do the quadratic formula. So A is equal to 1, B is equal to negative 3, C is equal to negative 10. And x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Like stop, it's in my head. I gotcha. So I get negative 3 plus or minus negative 3 squared minus 4ac all divided by 2a. Negative 3 is positive 3. Negative 3 squared is guaranteed to be? Negative 3 times negative 3 is guaranteed to be? Positive 9. Your calculator is going to show you it's negative. It's not. You know that's wrong. All right, negative 4 times 1, negative 4. Negative 4 times 10 is positive 40. That's square root of 49. What's the square root of 49, my friends? 7. So let's get our answers. 3 plus 7, 10. 10 divided by 2, 5. So that checks. 3 minus 7 is negative 4. Negative 4 divided by 2 is negative 2. And I will assure you this, my friends. Watching me do it, I can talk you through it. But I've been teaching for a long time, so I've come up with terminology I try to stay consistent with year after year. If you don't practice this, you're not going to get good at it. When you practice, you might make mistakes. Any of you that are in athletics, why do you practice for the game? Practice so you don't make the mistakes that you might have made during practice during the game, right? Okay. Keith,
Yeah.
you might know that. You know this better than probably most of us. About how many plays are in your guys' playbook? Just an estimate, you think?
Probably about 250 or so.
About 200, 250 plays?
Yeah.
Wow.
But I mean, it seems like a lot, but it's like the terminology and everything figured out. There's
Right.
because you can do all these combinations.
Right. So you might have one play that lines up the exact same way, where you're, in an offensive situation where you're probably going to look for the tight end in a situation, whereas you might, by saying a different word, but it's the same exact lineup,
Yeah.
where the wide receiver might get it, or you might be lined up the same way. You might say the same terminology, but you're going to have it as a running play. So
Yeah, well, yeah, there's probably 250, but then we have probably 4 or 5 different personnel packages. So that's whatever, 3 receivers versus 2 receivers and a tight end type of thing. So if you narrow it down, it's not that much.
Right.
Like, I only have to remember the route packages and the blocking schemes, that's it.
Because you play defense.
Well, no, so I was a tight end.
Tight end. Okay.
Yeah. But like, if you're the quarterback, you have to know everything. But if you're like a receiver, then when they say the play, you're listening for just one word. That tells you what to do.
Now, for the most part, let's say they said, we're going to run Mississippi, and I know that's not a play,
Yeah.
but we're going to go A Mississippi. And that A Mississippi might be the receiver to the left,
Yeah.
who's closest to the line. He might be A, and I'm just making up a term. So if they said A Mississippi, his job, the receiver's job is to make sure he's open and running a certain direction. He might be going down the line. He might be doing a slant route or something, right?
Yeah.
So obviously the quarterback looks, and if there's unbelievable coverage on that one receiver, then the other guys are kind of watching, saying, I might need to get the ball.
Yeah.
Right? So usually that takes place. Quarterback comes back, looks, sees what kind of coverage. There was the varsity game, the state playoff game 2 years ago, which you were still in 8th grade.
Yeah.
That was during the COVID years.
Yeah.
Gosh, I'm trying to remember who the receiver was. I think he went to, where did he go? Like Wisconsin or something? I can't remember.
Receiver?
Receiver, yeah.
Chase Henry?
Wasn't Chase. Black guy. Big black guy.
Oh.
Arnell or something like that?
You're talking about like last?
Two years ago.
So 2020?
Yeah. I just remember, whoever it was, he was like, I think he went to Wisconsin, I think. But Valor had their worst person covering him.
Yeah.
It was like, it didn't matter what the play was. He's getting the ball because you got the worst person covering the best. Yeah, it's Miles. Yeah, Iowa, right? Iowa State. All right. Hey, my friends, would you do me a favor? On page 163, will you try problems 4, 5, and 6? Do me that favor. Just try those. Just to see if you can figure it out. Cool. Really